Hello and welcome back to the final podcast in this series, looking at the development of this wheel assembly. So just to remind ourselves, we have currently built up the base plate, the bracket, the axle and the wheel, and we're ready to put it together. So this is essentially how we are going to assemble the components. So let's drag this off to one side and we'll get underway. So what I sometimes like to do, is to basically just show the objects on page. And where there's a small number of items of the assembly, that's handy enough. If it gets really large, we want to start considering, pulling some of the smaller items together into sub-assemblies and so on. But so that's for another day. So as we look at the parts we've created, we're asking ourselves the question: which one of these parts is everything else attached to? Yeah. And hopefully it makes perfect sense that the base plate is really the starting point for this, where we'll attach brackets either side, the axle and the wheel subsequently after that, perhaps. So with that in mind, if I just double click here on my bracket, how do I begin the assembly? Well, it's a bit like creating the drawings that we've looked at in class already. We'll come up to this area and click the drop down arrow. So we have the new option for something new. We have the option to make a drawing from this part maybe, or we'll have the option to make an assembly from this part. So let's go ahead and enter into assembly mode. You can see with the objects already open, they display here. If you don't have them open, you would then simply hit the browse button and go and find them. Before I start to bring anything in, a couple of wee things I need to do. First of all, I want to pin this on so that as I bring one object in, this whole properties manager here doesn't disappear on me and it stays on the screen. The next wee thing I want to do is to go to View, Hide Show, and pop the origin on the space so that I can locate whatever part I choose to bring in first, which, as we said, was the base bit. So with that selected, I come over to the origin. You see I'm on it, so I'm not picking up here, I'm not picking over here, I'm getting into the corner there, and I'm clicking and I'm popping in my base bit. So let's zoom out a little bit, give ourselves a bit of elbow room. Click on bracket. We want one bracket over this side, we want one bracket over that side. We want an axle, let's pop that over there for now. And we want a singular wheel, and we can pop that somewhere as well. So that's all my components in. As I say, with a small assembly like this, it's handy enough to bring these in. If it gets, a much larger assembly, you're going to control the stages that you'll bring the objects in. So let's go ahead and green tick and accept that, and let's go up to View, Hide Show, and just hide them origins again now that we have everything in. So if this is done correctly, the first part, if I left click and try to move it, you'll see the selected component is fixed, it cannot be moved. That's what we would like, as if it's bolted to a table already. And it's these other parts here that we're now going to move into and create the assembly from it. So a couple of wee things to get us started. Sometimes it's better to have the parts oriented into position. Take the bracket here, for example. It's once you orientate it around that way, and when I start adding bits or holes, I don't want to end up with my rib here pointing inwards. So it is a good idea, a good practice, just to get some of the parts pre-orientated. And how do we do that? It's nice and handy. We simply right-click on the component, come down about halfway here to move the triad, and we get these circles. Big circle that way is going to spin the component like so. This wee quadrant of a circle here will allow me to rotate like so. And this one will allow me to sort of flip it like so. So in my case, I want to grab this little quadrant circle just to rotate it around there a little bit. Get it into basic sort of position. I'll do the same here, move with triad, and I'll rotate it around like so into general position. And maybe while I'm at it, I'll go with the axle here and just rotate that right into an orientation more suited to where we're going to make these parts. Okay, so you've heard me use that term there, mating, and that's how we pull together our assembly in SOLIDWORKS. So I'm going to go to assembly mode here, and I've got my paperclip, which allows me to mate things together. We have different areas for mating. We have something called advanced mates. You can see different types down here, widths and so on. We'll be using the width one actually in this course. We have mechanical mates for things like cams and gears and rack and pinion, and etc., etc. And we have our standard mates to make faces coincident or parallel with each other, maybe even objects perpendicular to one another, or some tangency or concentricity and so on. These are what's called our standard mates. So I'm going to start off actually with a concentric mate. So if I zoom in here, I'm getting not the edge of my counter bore, but rather the cylindrical face of the counter bore. And that shouldn't match up with the cylindrical face of this object here. That makes sense, doesn't it? I could then also make this face, the underside, with this face here. You can see that slides down. It automatically picks up the coincident relationship there. Pops that down. So let's come out, let's rotate the part, see what it's done. Looks like it's there, but if I grab the part, you can see I can move it. But look, I can only move it in a certain way now. It is pivoting around the fact that the concentricity between these two holes here. Get the idea? So I'm going to add a similar one here to line up the other two cylindrical faces. And now that part, when I green tick on there, let me just come out of the mate here for a second so I don't select any other faces. If I try to move that, it's fully defined as it says. It cannot be moved because these two cylindrical holes are perfectly lined up with one another. So it is now fixed into place and at the right height as well. So let's continue with that process. Let's go back to mate, cylindrical face to cylindrical face. Green tick on that. Cylindrical face. Oops, that's clear on selections. I'm not sure if I'm good or bad. Because this was embedded in this here object, I think it was picking the wrong surface. So zooming in, cylindrical face to cylindrical face, like so, green tick. And then if I just click and drag, I can raise it up a little bit so that I can more accurately rotate the two faces and make them coincident, like so, green tick on that. So there you go, I've got my bracket, everything's fixed in place, working the way it's supposed to work. You'll also see that it doesn't, I can pass objects through here like you can do in the real world, so the order of assembling it isn't going to be critical for these last two components. I can fit the axle and fit the wheel after it is really not a problem. What I would like to do, however, is to center it up nicely rather than just putting it in, because I think there is a little bit of leeway here. So what I want to do to balance that out is add one of the advanced mates, what's called a width mate. And once we do it, it should begin to make a bit of sense. So let's click into Advanced. Let's click on Width. We've got two tab boxes here. We've got Width Selection 1 and Width Selections 2. The best way of possibly remembering this, is certainly the way I choose, is that the first box here is the widest part. Okay, so this axle has to fit in between the bracket, so the bracket has to be the widest part. So if I select the widest part as being here, and here, yeah, and then the narrowest part, well, that's got to be here and here. That's what's got to fit in. Let me just come out of that there a second. That's what's got to fit in. All we got to do now is add the concentricity between the shaft and the end here and the hole that's going to go into it. So if I add a mate now between that cylindrical face and this cylindrical face, and green tick, that actually will fully define it because it's already got the width mate. I don't need to line this one up. This is already concentric, so by default with this is straight. That is going to be concentric. And we've got it in as a width mate. So let's close that down a second, pick that face and go normal too. And there you can see what I mean by the width mate. I've got nice and balanced because it doesn't go all the way in. There's maybe room there for some kind of washer potentially. But rather than it being slightly to the left and a larger amount of this showing, it just looks better. So aesthetically, that's maybe the way that you might want to present this to a client, for instance. Okay, so the width mate. I'm going to do the same thing for the wheel. I'll maybe do it in reverse this time. I'll start by assigning a standard mate, which is the internal cylindrical face of the wheel, and the axle here, and actually get it located onto that. I could have done the same with the bit going into the bracket here, and actually get it going on. And then I could do the width mate afterwards to get it balanced, not over to one side, not over there, but get it right and nice in the middle. So I can do that now. I can go into my advanced mate. I can type in, I can click on width. And again, remember, it's the widest parts first. In fact, I'll make it easy for myself by dragging that out of the way there. The widest parts first, here and here. Then the narrowest parts, well, that's going to be this bit of the wheel, isn't it? And this little bit of the wheel. So it's pretty intuitive as to what we've got to do here. Let's just go and take an acceptor with him. So if I bring that on for a normal 2 view here, we can see it's all balanced. I can't drag that left or right. It's hard to see because it is circular. We'll try and capture something on it. I don't know if you can see some movement, but that is actually rotating, as you would expect it to do in the real world. Same thing for the cylinder. It is actually rotating. I can see a little bit of changes in the graphics on the screen there to let you know that rotates. But these other parts are all fixed into place. We have created a fully working assembly. Okay, well I hope that was helpful for you. Please don't forget to take it to the next stage then and produce the drawings from it. As I say, the assessment that you'll be having soon will entail starting off by actually creating the template, sheet formatting the template, before creating the part models, creating the assembly, and then creating the drawings of the detailed drawings of the components, the assembly drawing, bill of materials, bill of references. So check out those podcasts and you should be good to go. Thank you.